Hello and good day. I'm sorry, no. Howdy and good day, fellers. We are here in Algebra. We're going to go over the quiz from PO20. I had lots of questions on it. I thank you for giving me your feedback, what you understand, what you don't. If you left me a comment down at the end about something that you're not quite comfortable with, I sent you an email with that comment and my response in an effort to kind of bridge the gap for me not actually being physically here. If this whole thing works, I might just take the rest of the year off. My goodness. Okay, but so we're going to go over the answers here. A lot of you said that the most difficult part was with the graphs, which makes sense. That's probably you're least familiar with there. And so we are going to move on to CO21. Today. We will come back to the graphs later. We're going to kind of give it a rest. Most of you seem to be pretty comfortable with the equations for the most part, maybe a few misconceptions here or there, but hopefully we will get through those today. And then, future quizzes will come back to PO20 and just keep working on it, keep practicing with it. Some of you asked whether or not yesterday's quiz affects your grade. This still falls under the practice realm. I'm not expecting proficiency or mastery yet. That's when we come to the test. Yeah, don't worry about that. It's not going to affect your grade. We'll just keep carrying on here. I paused because I realized I wanted to share something else with you too. Before this video was played, you got your Unit 2 test returned. Your unit summary sheet and the actual test itself. For retakes, because the end of the try is quickly approaching, how it's going to work a little bit differently, just because I'm not 100% sure of my availability in the building going forward for the next couple of days here. Email me. I posted on Google Classroom, and you already have it, but I posted on Google Classroom all of the practice work from Unit 1 and Unit 2. Once you complete it, email me a picture. You can do this tonight. Email me a picture. I will then email you the retake, which you can print out, complete, take a picture of that, and send it back to me. The important thing that you need to do, because you are doing these retakes at home and not in school, usually on tests, I say that showing work is kind of up to you, whether you show work on the actual test. On the retakes, I am going to require all work to be shown. Not the practice work, because that is you're just practicing. You can do it kind of however you want to, as long as the answer is correct. But on the retake, I need to see the work shown. And I'll remind you of that fact when I email the retake to you. So whenever you want to get started on retakes, if you've got a free night tonight or tomorrow or Friday or over the weekend or whatever, email me a picture of your completed practice work, and I will email you the retake for you to print and then take a picture of that and send it back. Okay, so that's how it is going to work. If you got questions about your test, please don't hesitate to send me an email and I'll get back to you as quickly as I can. But on to the quiz. So a lot of you mentioned that it's not knowing which variable you are solving for, and it really all comes down to the language. Okay. If you have, this first one here, what is f of 10? And we're using f of x equals, too far, 3x minus 8 here. So what is f of 10? This is giving you the x value here, okay? It's telling you what is the value of the function when x is 10. And part of that is just, kind of memorizing what these notations mean. Those of you in geometry, I've talked before about how geometry is a whole new language. This is kind of the algebra language here. Understanding what this math word essentially means, f of 10, means it's giving you x, you're solving for y. Because remember that f of x is just another way to write y. Okay, so f of x equals 3x minus 8 is the same thing as y equals 3x minus 8. And f of 10 means that you're being given x and you're solving for y. So 3 times 10 is 30, minus 8, y equals 22. And that's where we get the ordered pair 10, 22, right? 10 being the x value. Ordered pairs are always in xy form. So x is 10, the value that you found for y, 22. Okay. Next one, what is g of 6? And you know what? I'm going to be using these equations further on down the line here, so I don't keep having to scroll up and see what they were, because with my memory, I'm going to write them down on the whiteboard over here. So we have 3x minus 8 for f of x, and negative 4x plus 15 for g of x. Okay, what is g of 6? Again, you're being given the value for x. Okay, this is just a fancy way to say y. So we have y equals negative 4x plus 15. This is the x variable. It's asking you to test 6 for x to get the value of the function, or the value of the equation. So g of x equals negative 4 times 6 plus 15, or just replace that with a y, because that's really what it means. Y equals negative 4 plus 15, and that gives us negative 9. So when x is 6, y is negative 9. That's what that order pair tells us there. 6, negative 9. Obviously, being multiple choice, I did kind of give you answers that you would get if you did something incorrect. So if you plugged in 6 for y, if you put, 6 equals negative 4x plus 15, and you solved that, then you would have gotten 2.25 as an answer there, right? That would be doing it backwards, okay? So not trying to trick you, but just trying to see, what mistakes you might have been making as going through this. All right, next two. This scrolls a lot faster than it does in the Word document, my goodness. Number 3 says, find x when f of x equals 13. Now, it's telling you to find x, right? And if the only variables that we're working with here are x and y, if it's telling you to find x, that means it has to give you y, right? And if we remember that f of x is just a fancy way to write y, we can really look at this as find x when y equals 13. So we go to our equation, which is a good thing I wrote it down because I did already forget what it was. F of x equals 3x minus 8. And instead of f of x, I can write y equals 3x minus 8. Well, I'm being told that y is 13, right? So we get 13 equals 3x minus 8. I'm finding x. And in order to do that, I have to know what y is, okay? So add 8 to both sides. You get 21 equals 3x divided by 3. 7 equals x. So the ordered pair is 7, 13. X always comes first. Whoops. Well, yeah, no, that's what I want. X always comes first. Okay? So x of 7, y of 13, 7, 13. If you plugged in 13 for x instead of y, then you would have gotten one of these answers. I forget which answer it is, probably the first one. But yeah, so it says find x. It's giving you y. Again, knowing that language. So down here, find x, right? When g of x equals 35, or find x when y equals 35. The reason why we don't just say y equals 35, why we write g of x, is to know that you're using the g of x equation. That's the other thing that we talked about function notation does, is it tells us which equation we are using, okay? So g of x equals negative 4x plus 15, or y equals negative 4x plus 15. We're supposed to find x, so that means they gave us y. Y is 35, subtract 15, divide by 4, and we get an answer of the first one, negative 5. Right? Subtract 15, 20 equals negative 4x, divide by negative 4, and we get an x value of negative 5. So negative 5, 35. Okay? So 2 examples of each type that you'll see there. I think the biggest hint as far as whether you're plugging the value in for x or f of x or y is that when it says find x, find x, they have to be giving you y. Okay. Then number 5 said, which is the greater value, f of 9 or g of 15? So this means, again, this is x here, right? Plugged into the f of x equation. Again, that's why we have function notation, so we know which equation we're plugging each of these things into. F of 9 is going to be into the f of x equation, which is 3 times 9. Whoops. Oh, no. Oh, and I'm dropping. I cannot go a lesson without dropping that eraser. My goodness. Every time I make it through a lesson without dropping it, I should get a raise or something. Because I just cannot handle it. 3 times negative 9. Hold on. If I knew how to edit it, I would edit that out, but I don't. So we just carry on. 3 times positive 9 is 27. Minus 8 equals 19. Then for g of 15, we're going to the g of x equation, which is negative 4 times our value for x, right? Because this also, is x here. Negative 4 times 15 plus 15. Negative 4 times 15 is negative 60. Plus 15 is negative 45. So 19 is the greater value. So f of 9 is the greater value. Just plugging those into each equation and solving. Now we get to the graphs. And this is where, like I said, a lot of people kind of had the most trouble with. Okay, on the graph, what is f of 6? So we're not using the equations anymore from above, because if you remember in the directions, it said, for questions 1 through 5. Now we're on question 6. Okay, so we're not using those equations from up above. It says on the graph, what is f of 6? So remember, this is our value for x. So since we're dealing with a graph, this is where the ordered pairs come in a little bit here. We're looking for an ordered pair with an x value of 6, and we want to know what that corresponding y value is. So we look for 6, x of 6 on this graph. The x's are labeled for you. Here's 6. The corresponding y value at x equals 6 is y equals 2. So when x is 6, y is 2, which is letter C. If you go through some of these wrong answers here, 6, negative 4, if you just plot that point, 6, negative 4, that's not on the graph, right? 6, 0, that's not on the graph. F of 6 is not on this graph. Well, it is, okay? When x is 6, what's the value for y? I'm hoping that a lot of you are sitting there going, oh, that makes sense, right? You all have that light bulb. It's just a matter of when it turns on, and it will for all of you at some point. Number 7, on the graph, what is x when f of x equals 1? So remember now, what is x when y equals 1? So in this case, we've got an ordered pair. We don't know what x is. That's why it's asking you for it. We know the y value is 1. So we go to the graph and we look for a y value of 1. So on the y-axis, positive 1 is right there. Just so happens we're on the graph, which makes our x value 0. So when y is 1, x is 0. That's what this ordered pair is, 0, 1. When y is 1, x is 0. So we have it here. Okay. If we look at the other incorrect answers here, 1, 1.5, well, that's on the graph, but it's not when y is 1, right? Y is 1.5. 1, negative 1, option C, well, that's not on the graph. Okay. So we're looking for the y value of 1, and x is 0. All right. Next one. Number 8. On the graph, what is f of 3? So again, it's that situation here where it's giving us x. Oh, there we go. It's giving us x, so we're looking for ordered pair or ordered pairs when x is 3. So we go to 3 on the x-axis. There it is right there. There's a y value. Actually, this is in green because this is the correct answer here. There's a y value here at 3, 2. And there's a y value here at 3, negative 2. So there are actually two locations where x equals 3, two ordered pairs on this graph that have an x value of 3, which is why, by the way, this graph is not a function, right? So I guess, technically, if I shouldn't be using function notation for a graph that's not a function, but if I didn't know it was a function yet, then what is the value of the function when x is 3? Well, sir, it's actually not a function, okay, because their x repeats itself. But both 3, 2 and 3, negative 2 are ordered pairs on the graph with an x value of 3, and that's why it is answer C. Okay. Now we get to some more contextual things. Okay. There's an oil spill in the Gulf. Oh my! Maybe you saw it on the news. Okay. How am I going to get? If I X this, will this? Oh, I should have done that earlier. Okay. Oil spill. The graph below shows the spill rate in gallons per hour as a function of time since the spill began. What does the statement F of 40 equals 800 mean? Well, in and of itself, this statement refers to the ordered pair 40, 800, right? X is 40. The value of that is 800. It's the ordered pair 40, 800, which is right there. Okay, so that was kind of step one. Step two was, what does that ordered pair represent? Is it between 40 and 80 gallons of oil have spilled so far? No. Ordered pairs are precise. They are locations. They are accurate. It's not an estimate. So that one's out. 800 hours after the spill began, the oil is spilling at a rate of 40 gallons per hour. Well, this would be, since that's our X value and gallons per hour is our Y, that would be the ordered pair 840, which is the opposite of what we have. Okay, so that one is at least plausible, but it's backwards. The third one, 40 hours after the spill began, a total of 800 gallons have spilled. This labeling here is important. That y-axis does not represent how many gallons total. It represents the rate at that particular time, the rate at which the oil is flowing from the rig. So it's not 800 gallons 40 hours later, it's 800 gallons per hour 40 hours later. Okay, so because it's not a total, that's why this one's out, which leaves D as the correct answer. 40 hours after the spill began, the oil is spilling at a rate of 800 gallons per hour. 40 hours after the spill began, that is X, 40. 800 is the rate of gallons per hour, that's Y, and there we have it. So this one was not only knowing the graph, but also interpreting it. And lastly, the spill happened at exactly midnight. So same graph as before here. The spill happened at exactly midnight. When was the oil spilling at the fastest rate? Well, the fastest rate the oil gets is 1,800 gallons per hour, which is the vertex of this graph here. That is at an X value of 16, which represents 16 hours later. Actually, quite a few people got this one correct. It's not 48 hours later. It seems that actually 48 hours after the spill happened, the oil stopped flowing because it's down at a rate of 0 here. It's on the x-axis, so that's good news. 1,800 hours later, that's the y value, not the x. And then right away at midnight actually, when the spill happened, that would be an x value of 0. It's going at about 1,400 gallons per hour. Okay, but it does increase up to 1,800 and then slowly decrease down to it being stopped. So there you go. There was the quiz. Like I said, if you get the equation part of it, the first 5, you're in a pretty good spot. We'll get back to the graphs, but this question, this will be on every quiz that I give you, whether I'm in school or not. Please do share with me. What things are you confused by? I'll do my best to kind of either just calm you down a little bit or steer you in the right direction. But that's going to be the best way for us to go back and forth. Okay. All right. On to the next thing, which I've already spent 20 minutes going over that quiz, a little bit longer than I thought I would, but that's okay. Okay. So on to CO21, which is, in the function family. I'll give you a chance to turn there if you haven't had your binders open. So turn to 21, look forward, it's after 20, before 22, 23, you got too far, okay, 21. Within the function family are linear functions. And linear functions are special in that they have a certain look to them or a certain shape. You can see that within the word linear is the word line. Okay, so a linear function is a line on a graph. Okay, it's the graph of a line. And what makes it a line is that it has slope, right? Slope is that constant rate of change that causes that line to move at a, constant rate, like a pattern. I think in PO22, we get deep dive into slope and how to calculate it, how to find it. But slope here, okay, is, you see this down below too, the rate of the change in y over the change in x. Another way to write this is a line's vertical change over horizontal change, right? The y-axis goes vertically, so the change in y is going to be the vertical change. The x-axis goes side to side, goes horizontally, okay? So the horizontal change is the change in x. You may have also heard the phrase rise over run. It's kind of a kitschy phrase. If it doesn't really tell you anything. Hey, calculate the rise over run. Like, what? What was that? I've never heard of slope before. What's rise and run? But the change in y or change in x is what we're really looking for here. Okay, and if the change in y or change in x is constant, that means it's got slope. It's increasing or decreasing at the same rate over and over and over again. That means it's going to be a line when we graph it on the corner plane. So here's what I mean. Let's look at this first XY table here. Okay. In these little wings to the table, we're going to write the change in y and the change in x. So going from -3 to -1, what's that change? Well, we're going up 2, right? From -3 to -1 on the number line is a change of +2. What about from -1 to +1? We're again going up 2. And then finally, from +1 to +3, well, that is again a change of going up 2. So the change in y is consistent here as we go through the table. The difference between every set of y values is +2. Now we go to the x side of the table, and we see if we also have a constant change. From +1 to +2, we're going up 1. From +2 to +3, we're going up 1. And from +3 to +4, we're going up 1. So every change in x is also consistent. If we look kind of across, this is going to get kind of messy here, so bear with me here. But if we look across the table, the change in y or change in x for the first set is 2 over 1. The second set is also 2 over 1. And for the third set, change in y or change in x is also 2 over 1. That means, yes, this is linear. Because that change is constant, okay, it's not varying, it's the same thing, then when we graph this, it's going to make a line on the corner plane. Okay? But you wish you had all these colors to play with up here, don't you? makes it kind of fun. All right? Let's look at the second one. Starting with our change in y, the change from 0 to 2 is plus 2. The change from 2 to 4 is plus 2. And the change from 4 to 6 is plus 2. So far we're in good shape, right? Things seem to be working out for us. Let's go to the x side of things. From 12 to 15 is plus 3. From 15 to 18 is plus 3. And from 18 to 21 is plus 3. We look across the table to see if we have a constant rate of change. Y is going up by 2, x is going up by 3, so the first rate of change is 2 over 3. The second rate of change, in red here, is also 2 over 3. And the third rate of change, in blue here, is 2 over 3. So this one is also linear, right? Because those slopes are the same. Okay, that rate of change is the same. Let's do the third one here. This one kind of always catches people, and here's the magic of math. Looking at the change in y, we have from 48 to 56. That's a change of up 8. Right? I'll circle them again so you can kind of see what I'm doing there. From 56 to 72, that's not a change of 8, is it? That's a change of 16. Uh-oh. Are we in trouble here? Well, not yet. Don't give up yet. Okay? Because our last change, our third change, from 72 to 80, we're back to plus 8 again. So maybe there's something else going on here. Okay? That would account for that positive 16 jump, and we can still end up with a linear function. Let's see what happens. Over on the x side, from 5 to 10 is positive 5. From 10 to 20 is not up 5, it's up 10. Okay. And then from 20 to 25, well, now we're back to plus 5 again. Interesting. So now looking across the table here, the change in y or change in x for that first set of ordered pairs is 8 over 5. And here's where things get magical, right? Because the second set, it's 16 over 10. But why do we always simplify fractions? Because the fraction 16 tenths simplifies to be 8 over 5. Da, da, da. And then the third one here, also 8 over 5. So don't give up. If it seems like it's not going to work out to be a constant change, go to the very end. Essentially what happened here is that we skipped over a set of plus 8 plus 5. You know, we just kind of jumped over it. And that's how we got the up 16 and over 10. Okay, but yes, these all being the same, it is going to be linear. Okay, so is this linear? Do that table there. Is this linear? That table there. Is this linear? That table there. And then if you're looking at a graph, like those middle two, well, remember what I said a linear function was. It's a line on a graph. Put on your big brains now. Is this a line on a graph? Yup. Does that mean it's linear? Yup. Is that a line on a graph? No, it's a V. Not linear. Okay? So graphs are easy. To tell if something's a linear function on a graph, you're just looking at it, is it a line? Not 2 like in a V shape or 3 in a triangle or whatever. Is it a line? Yes, it is. Linear function. No, it's not. Not linear function. And here's just where that change in y over change in x comes into play here. If I look at this line that we've said is linear, notice how I'm going up and over on x and y consistently. Up 1 on y, over 2 on x. Change of y of 1, change of x in 2. That's consistent throughout, right? Up 1 over 2, up 1 over 2, up 1 over 2. Because those rates are constant, that's what gives it the line. All right? Okay, the bottom section here, and then I will stop talking so you can get to work. It says make an XY table with at least 4 ordered pairs of a linear function with a slope of -2/7. What this means is, and that negative sign can either go with the numerator or the denominator. It would mean the same thing. But basically, I'll go with this first one here. In my XY table, I'm going to pick a number, 5, and pick a number, 1. Okay? If my change in y is down 2, that means my next y value is going to be 5 minus 2, which is 3. If my change in x is +7, because this negative sign doesn't belong to both the 2 and the 7, it's only one of them. I put it with the 2. That's why I went down 2 in my y. But for my x, that change in x, I'm going up 7. 1 plus 7 is 8. Right? And then down 2 again for y, that gives me 1. Up 7 again for x, that gives me 15. Down 2 again for y, -1. Up 7 again for x, 22. Right? I've got this -2, -2, -2, +7, +7, +7 relationship there. Now you can't use 1 and 5 as your first numbers here in your XY table. You can't just copy that down. Okay, you've got to make your own. All right, but there you have it. That is your crash course on linear functions. You're looking for that slope is the change in y over change in x the same. Okay. Your homework is to finish CO21 and then do the short quiz that I've posted for you in Google Classroom. That, folks, is how you math. Don't forget to like and subscribe, and have a tremendous day. Oh, cons due tomorrow night. Bye.